Okay, we are going to do letter A. And even though every teacher always says number A, and that drives me up the wall. Huh? People say it. Everyone has had a teacher that has called it number A. Yeah, everyone has. All right. First one's easy. We don't need to think too hard about it. Because technically, it's just a rectangle, right? And the rectangle is length times width, plus width times height, plus length times height, times 2. But since all the numbers are the same, all you got to do is recognize that that is a square, and it's 5 squared, which is 25, and there's 6 sides. So it's 150. Okay? Now, second one. He got 125 because he did 5 times 5 times 5. He wasn't reading. Yes. All right, next. This is what I'm saying about this. It's always easy. 5 times 5 times 6. It's not hard math, but if you don't pay attention, you screw it up. Let's look at the next one. So let's pretend that you don't really know what you're doing, which is not true because you guys are all smart kids. You look at this and you say, okay, well, there's that shape. And what shape is that? It's a triangle. How many of them are there? 2. So a triangle is base times height divided by 2, isn't it? Yeah. But there's 2 of them. So I multiply by 2, then what happens to the 2's? They cancel out. So base times height will cover the front and the back of this, won't it? Yeah. Right? So that's 8 times 6, yes? Mm-hmm. So I know the front and the back are 48, right? What's the bottom? Because I don't want to call it the base. 8 times 7, because it's a square, or it's a rectangle, right? So the bottom, since it's just a rectangle, my computer's frozen like it always is, we know that it is length times width, we know that it is 8 times 7, and we know that it is 56, yes? Okay. What is this side of it on the back? Is it another rectangle? Yeah. Right. 6 times 7, which is 42, right? Yeah. So it's the only... Yes, he should...
Can you slow down a bit?
Oh, I'm recording it. But indeed, I can slow down. So, is everybody cool with all the 3 sides that we can find? So the only problem we're left with is this rectangle here, right? We can see that it's a rectangle, right? And we know that a rectangle is length times width, right? We know we have one of those dimensions right here. It's 7, yes? But I don't have the slanted side. I do not. But what did we learn yesterday if we ever needed to find a slant and a triangle was involved? A squared, B squared, C squared. Okay? But I'm going to make a small change here. I'm going to erase everything I've done on the triangle. If A squared, B squared, C squared is going to be used, then what kind of triangle must I have? A right angle triangle. Is that a right angle triangle? Yes. Look again. Does it have this? Does it? It would if it wasn't shaded. You can guarantee that. How? The point of it, Sam, is this. Listen to me carefully. The point of this question is this. I am very happy if you've tried to use Pythagoras here. Okay? That shows a lot of thinking about math. Right? The problem with it is you made an assumption that is not supported by any data. Right? Is that a 90-degree triangle? You do not know that it is. Tasha says it doesn't look like it is. But Tasha, if I put that there, even though it doesn't look 90, would you make it a 90 degree? Would you do Pythagoras on it? Yes, you would, because it's there. Do you understand the difference? So if you did Pythagoras you of course found that this side was 10. Right? Right? And then you knew that this was 7 times 10, which gave us 70, correct? And then what did I do with 42, 56, 70, and 48? Added it up. Is everybody cool with that? And if you did that, I would indeed give you almost full marks. But in reality, is this question possible? No, because you don't know that number. And right now, you don't have the math tools to find it. Because Pythagoras technically doesn't work here. Now wait. There is something else you could have done here. So anyway, the answer was something like 216, yes. If you did Pythagoras. Now, I want to show you something. What if I do this? What's that? It's a rectangle prism, isn't it? Which is exactly double this triangle, yeah? So if I did rectangle prism, which is 2 LW plus WH plus HL, if I did that, which is about to show up in a moment, when my high quality machine works again, any second now, possibly soon. There we go. I lost half my drawing. But then I could put in my numbers, couldn't I? And I would have 2, 8 times 7, plus, just wait, Isha, it's not as easy as you think. 8 times 6, plus 6 times 7, correct? Right? But it's not times 2, is it? Because we cut it in half, so it would be just times 1, right? Are you cool with that to there? Now, if we did that, we would get an answer of 286. No, I lie. We wouldn't get that. We would get 146. Now, I've told you the answer is 216, yes? So how can doing this, because it is half a prism, isn't it? Yeah. How does half a prism get me the wrong answer?
Because it's not like the triangle.
Nolan? Right. Once I cut it in half, I got to add that 70. So if you did cut in half like that, because you recognize, hey, that's half a rectangle prism, Myers, you can't fool me, then you still got to remember that we got new here. Everybody with me? So is it okay to have done that? Is it okay to do it as a prism cut in half and then add the slanted part? Yes. Is it okay to find all 6 sides and add them? Yes. The whole point of this exercise is all we're ever doing is length times width or base times height, isn't it? Which isn't difficult. Then we got to put it together, which is difficult. Picking up what I'm putting down. Okay. Next one. Anything special about letter C? What is it? It's a rectangular prism. Can I follow the drawing? If you look on your sheet, this is labeled as H, this is labeled as L, this is labeled as W. And then you just fill in the sheet, right? Because it's 2 LH plus HW plus LW. And you just put the numbers in, correct? I don't want to write it out. What did we get for an answer? Somebody tell me what they got. 192 is correct. I remember I've done this twice already today. It is indeed 192. Is everybody cool with that? Okay. TJ and Nick. TJ. I am not accusing you of anything. I am saying there is noise coming from your corner. Since I am looking down, I do not know who it is. Alright? You're not in trouble. It's just a reminder that I have something to say right now. And Nick has ears. And he is wisely going to stop going, shame, shame on you, because he is wisely understanding that this entire lecture is also directed at him. And he is going to sort himself out. Or he is going to remember the very first day when I said you can sit wherever you want until you piss me off there. Because I got a desk right here that's minding its own business and is desperately looking for an ass to be in that seat. Got it? Good. Now, as I was saying before I had to give the small lecture, when you do D, every single one of you in grade 9 did these figures. They're called composite figures. Most of you probably learned the same way, which was you looked at that and saw two different shapes, yes? You saw this shape, which is a rectangular prism, yes? And then you saw this shape, which was a cube, yes? Well, it's 4 by 4 by 4, right? It's a cube. So what you had there was an R prism plus a cube. And then, of course, you remember that because this square at the bottom is overlapped, it is removed from the total surface area twice, because you lose it on the cube and you lose it on the rectangular prism, right? How many of you were taught that in the 9th grade? Be honest, it's not right or wrong, just if you were taught that at some point, say so. Yes, Jack, you were indeed, but then you learned a better way, which I'm about to show you. Okay, everybody cool with that? Now, here's the way I like to do questions like this. What if that extra cube wasn't there? What do I have? Rectangular prism, yes? 2 LW, LH, HW, right? Super easy to do. Yeah? Right? Right? But it is there. So when I did 2 LW, LH, did that cover all of this green? It did, didn't it? The only thing that was added was this blue. How many times? 2? 4. 1, 2, 3, 4. In this case, it's a cube, so it was added 4 times. If it was another rectangle, James, it would be plus or times 2 and times 2, wouldn't it? So, is it okay to do 2 LW, WH, HL plus 2 LWH, HL, LW minus 2 LWs? Is that okay? But it's a lot of work. I would rather go 2 LW, WH, HL, and then I'd like to add the 4 LWs. No subtraction, and I got to do way less work. Does everybody see what I did there? Right? Aiden.
Could I just do 4 times 4 to the power of 9, because that's how many 4 times 4 squares there are?
I was just going to get to that.
Okay, and then just do the...
You beat me. The way I handle that, the situation you're describing, is I say, great, now I can think of another way to do this. Who has it? And then you would have done, I do. But you ruined my whole thing.
Sorry.
That's okay, Aiden. We're just getting to know each other, and you wouldn't know yet that I would have known that there was another way and somebody would have figured it out. But yes, you absolutely could have done that. What Aiden is saying, guys, is isn't this also cubes? Right? But you did 4 times 4 because there are 1, 2, 3, 4, 9 faces of 4 times 4.
Yeah, on that, picture as a whole.
Yeah, absolutely. Yep. So the answer, if I'm not mistaken, was 288. Everybody cool? Okay. Do we continue or do people need some time with this one? Oh, crap. You guys got the wrong page. That's supposed to say 7.1.
That's not even in our book.
Yes, that is.
Page 31. That's supposed to say 7.1 on your guys's. No, it actually makes it possible. It needs to be 7.1. Okay, so I'm going to pause, let you guys get back. Pretty soon in the year, Isha, I'm going to start just talking real quietly and teaching to the 4 people that listen to me. Then I get like 3/4 of the way through a page before everyone else figures it out. And they're like, Mr. Myers, can you go back? No, because I said, all right, listen up. And you chose not to listen.
Yeah. Why don't you do that now?
Oh, because it's too early yet. It's only the second week, right? People need to understand. I'm a pretty quiet guy, Jake. It's sometimes hard for people to hear me when I say, all right, listen up. See? I'm pretty quiet. It's hard to hear. The other teachers on the floor sometimes say, Myers, why are you so quiet? I'm being sarcastic, Jake. There's a reason every doorway on the 3rd floor hall is closed.
Whoever watches this after and hears that, like, little thing after, will be like,
That's why I have the video. Because right now, it's recording how poorly behaved a great many people are in this class. And pretty soon I'll start saying names. And then parent-teacher night's going to come up. And then the parents are going to come in and say, my kid says he can't get anything done in your class. I'm going to say, oh, really? Is your kid bleh? And they'll say, yeah. I'll say, oh, well, how about we watch these videos? And it will be me 50 times a class. Blah, stop, blah, stop, blah, stop. That's why your kid can't get anything done in class. And then the parent goes, interesting. Never apologizes for coming in and being mean to me.
yeah, they just
But leaves different. And
Yeah.
that's okay. I'm all right
at
with
least they
that.
leave different.
Yes. I know it's recording. So, okay, so here we go. So in this question here, obviously there are no formulas we can do there because we don't have a formula for a triangle prism. We have to work it out face by face, yes? So that overlap thing that you learned in grade 9 doesn't really work. You're kind of screwed there. So what you gotta end up doing is going face by face. You gotta go face by face with questions like this if there's no formula. So what I like to do is always write it out without any numbers in it, because then you can't screw it up, right? I know that this end is 2 LW, right? LW, because there's a top and bottom. There's my LW. There's 2 of these, right? Which is LH, LH. But there's only one of these, isn't there? Right? So I don't want to put that in with my times 2, right? This is just plus 1 WH. Is everybody cool with what I've done there? There's the blue, there's the purple, and there's the orange. Everybody good? And that covers this side of the business. Now when we go over to the triangle side, we know that the green side, because it's a 90-degree triangle, I know that this is the base and this is the height. And I know that there's 2 of them. So instead of going base times height divided by 2 times 2 and canceling, I just say to myself, base times height covers all the green. Right? Then I got to add the yellow, which is what? It's just a rectangle, isn't it? So the yellow is an LW. Then I got to add that side. Can I do that side right now? Right now? No, because something's missing. What's missing? The hypotenuse, right? Now, we've done enough Pythagoras, at least we should have, to automatically know that 3, 4 makes a hypotenuse of 5. Just like 6, 8, 10, right? So we know that's 5. So we know this side is 3 times 5. And I'm putting numbers in there instead of letters because I can't show you that face, right? From a teaching perspective. If I was just doing this question, I do this part in my head and then I put the numbers in, right? So you guys would work all this out to the LW is 8 and 3, right? So that's 24. The purple side is 8 and 3 again. That's 24. The orange side is 3 by 3. The BH is 3 by 4, which is 12. The LW, actually I should have written out 3 by 4. Sorry guys. 3 by 4, which is 12. And then finally, BH 3 by 4. This yellow 3 by 4. And then finally 3 by 5. Now, everybody gets all up in arms. Oh, Mr. Myers, the math is so hard in grade 10. Multiply, add, multiply. Multiply, 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 multiply. Add, 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 add. When did we learn adding and multiplying? Grade 1. Is the math in grade 10 hard? No. Does the math in grade 10 take thought? Yes. Does the math take the thought or does the method take the thought? The method, right? So the answer there ends up being 144.
I got it.
How did I get the 5? Did you just ask, Riley? Okay. Okay. I'll quickly review Pythagoras. 3, 4. What's 3 squared? 9. What's 4 squared? 16. What's 9 plus 16? 25. And at the end of Pythagoras, you square root. Okay? I know, right? He whines the whole time. But at least he's nice about it. I get students that get mad at me when they see this, like, it's easy. Stay cool, buddy. I know. All right. So I told you this side was 7.1, yes? So do I have a formula here? Huh? Oh, you guys already did it as 8? That's cool. Because it's going to be the same method. The only reason I changed it to 7.1 is because if it's 8, it's an impossible triangle. It can't be 5, 5, and 8 and still be 90 degrees. So, I can't use a formula. So I got the green side. How many of them are there? 2. I got the purple side. How many of them are there? 2. I got the bottom. How many of them are there? 1. Because the top here doesn't exist, right? So that's going to cover the roofs and the walls, because say it's a barn, right? Then I got this. How many of them are there? 2. And then I got this. How many of them are there? 2. And then it's just the exact same thing we've already been doing. So everything that's a rectangle is super easy, yes? What's the green guy? 15 times 5 times what? 2. Excellent. Plus, what's the purple guy? 15 times 2 times what? 2. Perfect. What's the bottom? 15 times 7.1 times 1. I couldn't fool you. Excellent. What's the triangle? Now here people have trouble. What's the formula for a triangle? Base times height divided by 2, right? If I draw this triangle this way, and you are not thinking like a grade 10 student, where do you say is the base? 7.1. Which would mean you would need a height, wouldn't you? You can't find that height without doing Pythagoras, yes? But because it's a 90 degree, isn't that the base and height? So it's 5 times 5, right? Which is 25. Because we don't have to divide it by 2 because there's 2 of them, yeah? So I add 25. And then I add it all up. So I get 150 plus 30. 15 times 7.1. I can't do that in my head. I wish I could. It's 7 times 15 is 70. It's 105 and 106.5. And then I would add it all up. Oh, wait. I missed one. I forgot the yellow, didn't I? 7.1 by 2 by 2. 7.1 by 2 by 2. So I got to add another 28.4, and then I add it all up. And I think I get 369.7. Well, that's if you guys do... Oh, you did that? Okay, so 263.
So final answer is 263.
I believe so. I did it all in my head, so... Again, the point, Isha, is that you get the concept, right? Okay. This question. Are you allowed to do the grade 9 thing where you cut it in half and do overlaps, or cut it in half this way and do overlaps? That's okay, right? Watch this. What if I do this? What did I just make? Rectangular prism. So would I be allowed to do 2 LW, LH, WH? I would, right? And that would cover everything except what? The part that's cut off, which is just that rectangle and that rectangle, right? Because the roof is still there and these walls are still there. So how big is that yellow rectangle? 2 by 11. So it's 22 feet squared, right? And how many of them are there? 3, 4, 2. There's one there that got cut off and one there that got cut off, right? So if I do a whole rectangular prism and I take away 2 times 22, will I get the right answer? I will, won't I? Now, is it wrong to do 2 LW, LH, WH plus 2 W, LH, minus 2 overlaps? Is there anything wrong with that? No, but it's a lot of arithmetic, isn't it? It's a lot of steps. How many steps is this?
2.
Just 2. Everybody understand? Will you get the same answer? Sure you will. And I think it's 444. But I don't remember. Has anybody done that question? Did you get 4? Well, we did it together. We get 444? Yep. Okay. Everybody cool? Yeah. Everybody good? Okay, turn the page over to the last one. Anything funky about a cylinder? Not at all, right? It's got a formula, right? And it's not a tricky formula. 2 pi r squared plus 2 pi r h. Myers, how'd you know that? I've done this formula 1,000 bazillion cajillion times. You haven't. So where do you get the formulas?
On the sheet.
On the sheet that you get to use on every test and quiz. You don't have to memorize it. Okay? So 2 pi, what's r? Radius, and in this case it is 3 squared plus 2 pi, what's r? What's h? 8. What if I drew this cylinder this way? 3 and 8. Is that still the height? Yes. Will I fool any of you on your test with that? I better not. Now, next thing. Fill it in. What's 3 squared? Times 2? 18 pies. Plus, what's 3 times 8? Times 2? 48 pies. 18 pies, yum. 48 pies, yummier. How many pies in total? 66 pies. Is that right? Yes. Is that the answer I want to see? Yes. What if you're writing a multiple choice test that doesn't have that? It only has numbers. How do you solve that? 66 times the pi button, and you get something like 207 blah. Everybody cool? Everybody good? Now wait a second. I want to do something with this. I'm going to use colors. What part of the cylinder does that give me the area for? The circles, which are what? The top and the bottom. Unless I turn it sideways, right? The base shape. Agreed? What does that get? Oh, it didn't change color. Now I look like an idiot. Thanks, buddy. Where does the green get me? This part, right? So what if I told you I had an open cylinder? What would you do for surface area? Means it's got no top and bottom. Totally open. What would the surface area be? You would get rid of which one? The blue or the green? Blue. And what would you do with the green? Why would you double it? Because it's outside and inside, yes? What if I told you that it had one? It only had a bottom. What would you do?
You would double the green and keep the blue the same.
Yes, you would keep the blue the same because the inside and the outside of the blue is still doubled. Excellent. What if I told you I had an open-ended cylinder, but I was dipping it straight down in paint like this and stopping? Now what would you do? I'm right, the paint's up to here.
Wait, so the paint does hit it.
The paint does not go inside, so what is the surface area?
The surface area of what's inside of the surface area with the paint.
I pulled it out of the paint, so what was the surface area that was painted? The outside of the bottom. So how many circles? One. So would we need that too?
No.
So it would be pi r squared. Would I need that too? Yes. Everybody with me? Okay. What if I told you I was frosting a cake? I'm stopping right there. Great. Great. I know you did, TJ, because I taught it to you. Okay. Guys, listen, please. The last question is open to interpretation. That means there's a lot of ways you can solve it. What am I looking for? That you do the right math for how you decided this room looks. Understand? Does everybody understand what I mean by that? Yeah. You have a choice of how you're going to handle that problem. Everybody cool? Sweet. And it's 2:19. You're out of here in 8 minutes. You could get that done. Or, because it's Friday afternoon, you can talk amongst yourselves. But if I choose to have a conversation with my good friend Isha, and my voice has to go above this level for her to hear me, you don't want to be one of the people that's making my voice have to go above this level. Do you understand what I am saying? Yes. Good. Outside to the compost, yes. No. Nobody can leave. You know the rules.